quadratics comprises of four aspects: the quadratic expression, the quadratic equation, the quadratic inequality, and the disguised quadratic equation. So let's begin with the first type, that is quadratic expression. So do we know what is the difference between an expression and an equation? To simplify this statement, an expression is without equals to zero sign, and in an equation there is equals to zero. So this means if someone is saying y is equals to 2x square plus 3 plus 5x minus 8. Now this is a quadratic expression. Few students have a misconception that there is an equals to sign, so this is an equation. No, it is an expression. But if we are going to say that y is 0, then if we are going to substitute 0 in place of y, then it would become 2x squared plus 5x minus 8 equals to 0, in which case it will become an equation. So this is an expression and this is an equation. So the first category is quadratic expression. The quadratic expression, the general form is y equals to ax squared plus bx plus c, where the value of a determines the nature of the curve. We should note here that the coefficient of x square determines the nature of the curve. If the coefficient of x square, this value, is positive, a greater than 0 would mean if the value of a is positive, then this would mean that it is a minimum point. And if a is negative, if the value of a, which is basically the coefficient of x square, is negative, then there is a maximum point. Now, how can we remember this point? Because at times when we are saying a greater than 0, students are saying it is a maximum point. It's not like that. Just to remember this point, when a is positive, just imagine if there is positivity all around you. If towards right there's positivity, if towards left there's positivity, everyone is happy, everyone is smiling, then you will smile and there would be a smiling face, the happy face. So this means when the coefficient of x square is positive, if there's positivity, then we are all happy. So happy face gonna be made and there would be a minimum point. So we are saying happy face, right? And then if we are talking about a negative, if there's negativity all around you, then you are gonna be sad. And if you're gonna be sad, then the point would then be maximum point. Just to remember, if a is positive, it's a minimum point. With positivity, we link a smiley face. With negativity, we link sad face. And this is how we can remember. So if, let's suppose if I'm dealing with this expression, minus x squared plus 2x plus 8, would there be a minimum point or a maximum point? Because the coefficient of x squared is -1, this means there would be a maximum point, right? So here we know that whenever we have to find the coordinates of a particular turning point, the stationary point, and we have to determine the nature, then how can we determine the nature? By just looking at the coefficient of x squared. If it's positive, it's a minimum point. If it's negative, it's a maximum point. Now let's focus more on how to find the coordinates of turning points. Sure. If I'm gonna ask a question, then I'll ask a question. I'll throw a question towards you, and then I'll expect a response in the chat message. That would be great. So that way, I would be knowing that whether your competence level is up to the mark or not. All right, inshallah, I'll do that. No, don't worry at all. Right. So I was saying that now we have to find the coordinates of turning point. Right. Now in AS level mathematics, whenever we have to find the coordinates of turning point, now firstly the concept is, what is a turning point? What is a turning point? So when we are going to draw a graph, the graph will turn at a certain point and it will come back. It's going up, it will turn and then come down. If it's going down, it will turn and start going up. Just like when you're driving a car and you take a U-turn, You're going towards north, you take a U-turn, you start coming towards south. You're going towards east, you take a U-turn, you start going towards the west. Similarly, the turning point is a point where the curve turns, and if it was increasing, it starts to decrease. If it was decreasing, it starts to increase. So this means the direction of the curve changes. And that particular point would then be known as the turning point because the graph or the curve turns at that point in time. So in the first category of quadratics, the quadratic expressions, our objective is to determine the coordinates of turning point and to determine the nature. To determine the coordinates of turning point and the nature. There are two aspects of turning point. One of them is coordinates and the other is nature. Whenever we have to find the coordinates of turning point, either we can use this particular form, the raw form of quadratic expression, the original form, or we can convert the original form to completed square form and then find. At times, students have a confusion. They think that whenever they have to find the coordinates of turning point, it is mandatory and essential for them to convert the quadratic expression into completed square form. This is not the right thing. This is not the right concept, I would say. Whenever you have to find the coordinates of turning point, you can find it directly using this form. There's no need to convert into completed square form. However, in few questions of functions in quadratics, the first part tells us to convert into completed square form, and it's only then that we are asked to give the coordinates of turning point. In those cases, we will be converting into completed square form in the first part, and then we'll be using that form and give the coordinates in the second part. But what if the first part of the question says, determine the coordinates of turning point? Then will we have to convert it into completed square form using a lengthy approach by wasting a lot of time into it? No, it's not essential. If the coordinates of turning point are asked directly, then without conversion into completed square form, we can find that out. How come? Now here comes the formula. For finding the coordinates of turning point, from this particular form, the simple formula that I have written over here is x is equals to negative b upon 2a. We all know the coefficient of x square is known as a, the coefficient of x is known as b, the constant which is without an x, without the variable, which is just a constant at the end, is the c. So this means whenever we have to find the coordinates of turning point using this form, what we can do, we already know the nature using this form because the coefficient of x square is negative. We know that it is a maximum point, right? We know that it is a maximum point. So that is why the only thing that we need to do now is to find the coordinates of turning point because the nature is already found. Nature of turning point means is it a maximum or a minimum? And the coordinates would mean x comma y in this form, x comma y form, in coordinates form. And nature would mean it's a minimum or a maximum. So with this form, we can determine the nature easily. But how to find the coordinates of turning point? The formula is x equals to negative b upon 2a. So if this is the example that I've given, an examiner tells me to find the coordinates of turning point, do I need to convert it into completed square form? No, it's not essential for us to convert. We can directly use this formula. How? Negative b upon 2a. So b is 2 and a is negative 1. If you just write coefficient of x square is negative 1, so a is negative 1 and b is 2. So minus b upon 2 times a, and a is negative 1. This means minus 2 upon minus 2, negative 2 upon negative 2 is 1. This means the coordinates of turning point, the x coordinate of turning point is 1. Sir, but when we are talking about coordinates, we need the x coordinate as well and the y coordinate as well. You have just found the x1. How can we find the y1? To find the y coordinate, you need to substitute the x coordinate into the original equation of the curve. And that is what is written over here. When you have found the value of x, the x coordinate of turning point, You need to substitute this x coordinate in the equation of the curve. And in this example, the equation of the curve is negative x squared plus 2x plus 8. So let's find the y coordinate. Y equals to negative 1 square plus 2 times 1 plus 8. 8 plus 2 is 10. 10 minus 1 is 9. So y is 9. Someone is telling me find the coordinates of turning point. I'll say definitely I can. 1 comma 9. Now, is it a minimum or a maximum? I already know that it is a maximum point. So the coordinates would then be maximum point 1 comma 9. So here we understood that we are not bound to convert into completed square form before we can find the coordinates of turning point. The question here is, sometimes they ask for 2x coordinates. Listen, sometimes they ask for 2x coordinates. When they are asking for two, they never ask for 2x coordinates. They in the topic of differentiation, they ask for multiple turning points, coordinates of turning points. Now we are not at the moment discussing differentiation, but as far as 2x coordinates are concerned, that is not the turning point. That is the roots of the equation, the quadratic equation roots. I totally got your point. Let me elaborate this point so that it clears your confusion here. If it's x square plus 5x minus 6 equals 0, right? Now this is an equation. This is not an expression. So if we need to find if the examiner says solve the following equation, solve the equation. Examiner is saying solve the equation. If the examiner is saying solve the equation, then we have three methods: factorization, quadratic formula, and completing the square method. But usually we prefer factorization. And if you are unable to factorize, we follow the quadratic formula. This is what we usually do. So over here, let's suppose if this is the equation and we have to find the 2x values as has been asked in the chat, what we are going to do is we're going to prefer factorization. Can we factorize here? Oh, yes, we can. How? Is the middle term breaking possible? How do we do middle term breaking? We multiply the first and the last term. It's negative 6x squared. Then the two factors of negative 6, which when multiplied give us negative 6x squared, which when added or subtracted give us the middle term. Which two factors are those which will add and give us 5x? Are there any factors? I'll say yes. 6 into 1 plus 6 minus 1 when multiplied give negative 6, when added give plus 5x. So here we are successfully able to middle term break. 6x minus 6 equals to 0. We are successful in breaking the middle term, and now we have taken the common. We have making the pairs, two pairs. X plus 6 is then taken as common. This is x minus 1. And then we have given two x values. One of them is 1 and the other is negative 6. So these are not the coordinates of turning point. They are the roots of the equation. The roots of the equation is a different story, which is the type 2 of quadratics, the quadratic equation category. I'm going to explain that in more detail when I'm going to move on to the quadratic equation one. But firstly, it's important that we understand the quadratic expression one. So it was, I guess, Malaika, you asked the question. Are you clear with it? Were you talking about this? 2x coordinates. So these are not the turning points. They are the roots, or they are the x-intercepts, or they are the solutions of a quadratic equation. Solve the equation, we solve it, we find solutions. Solve the equation, we find the roots. And the roots are the values where the curve crosses the x-axis. These are the roots. These are the roots. If I have been able to find 1 and negative 6, then this means this is the case like this. This is negative 6, this is 1. This means the curve crosses the x-axis at negative 6 and 1. The curve crosses the x-axis at negative 6 and 1. So negative 6 and 1 are the roots of the equation. Now comes the question of Musa. Musa has asked, sir, how come this is a maximum point? As I said, this is the form that you need to check out. This is the quadratic expression, right? The coefficient of x square. I'm writing over here. The coefficient of x square determines nature. Coefficient of x square would mean the number which is written with the x square. So over here it's negative x square. What is the meaning of negative x square? What is the meaning of x square? X square means there's nothing written. It means it's a 1. If it's negative x square, this means it's negative 1x square. So the coefficient of x square is negative 1. As I said that whenever the coefficient of x square is a negative number, then this is going to be a sad face because of the negativity, and a sad faced curve has a maximum point. And if the value of a is positive, then if it's positivity around us, we are going to be happy. It's going to be a minimum point then. Have I cleared the confusion? Yes. Okay, perfect. Right? So here, what I've clarified is, okay, whenever we have to find the coordinates of turning point, we have to, do we have to convert it into completed square form? Are we bound to do that? Or can we just get rid of the completed square form and just give the coordinates of turning point and determine its nature directly? So we have learned the skill that we can do that directly without the conversion to completed square form. By looking at the coefficient of x square, we determine the nature. And by using the formula x equals to minus b upon 2a, we find the x coordinate of turning point. And by substituting the value of x in the original equation, we find the y coordinate of turning point. So that way we have found the nature as well as the coordinates of turning point. Have I cleared the confusion of everyone? Is everyone clear till here? Please acknowledge. Anyone to share feedback? All right, just take a screenshot of this so that we can move forward. You can make notes later on if you want, right? All right. Now comes completed square form. How do we convert into completed square form? And how do we interpret completed square form? Two major tasks. Without the conversion to completed square form, can we find the turning point? The answer is yes. Can we determine the nature? The answer is yes. But let's suppose, sir, if in the first part we are told to convert into completed square form, how will we convert? And if in the second part we are told to utilize that completed square form to give the coordinates of turning point, how can we do that? So firstly, I'm telling you how to utilize and read the completed square form. It's only then that we will learn how to convert into completed square form. The first task is to interpret the completed square form and to get something out of it, to get nature and coordinates of turning point out of it. And then we'll learn the skill of converting into this form using the original form of quadratic expression. So now first, let's learn the interpretation with different examples. Here I have written the general form of completed square form which is y equals to ax plus b whole square plus c, in which we can see that there's a bracket and the whole square at the top of it. And inside the bracket, there is a function in terms of x. This is a linear function. So a bracket open x plus b whole square plus c. So if we are given this form, how can we find the nature? How can we determine the nature of the turning point? Let's understand the nature part first, and then we'll move on to the coordinates part. So if we are to find the nature using this form, then the coefficient of this bracket, which is basically the value of a, determines the nature. And beware that in the quadratic expression, in the original form, if we have a, this is the same a as this a. They are both the same. Using the original quadratic expression, we can determine the nature. But if we have completed a square form, then also we can determine the nature. How? The coefficient of this whole bracket determines the nature. This value of a is the same as this value of a. Again, the same concept. If the value of a is positive, if it's greater than 0, this means if it's positive, there's a positivity all around us. We are being happy, smiley face, minimum point. A negative, less than 0, negativity all around us. We are sad, the maximum point. Just to remember the concept forever. I'm just using these terminologies so that you never tend to forget. So nature, we have found the nature. We can find the nature using the value of a. I'm gonna give the example soon. And then to find the coordinates of turning point, concentrate and just listen to what I'm saying. To find the coordinates of turning point, the linear function inside the bracket is to be equated to 0. The linear function inside the bracket is to be equated to 0. So if there's a x plus b inside, we are going to equate x plus b equals to 0, and we are going to get the value of x. So it's x equals to negative b. Whatever the value of x we are going to get will be the x coordinate of turning point, right? And then when we are going to substitute this x value again over here, let's do that. If x is negative b, let's suppose, and if we are substituting negative b over here, it would be like this. A, in place of x, we are substituting negative b plus b whole square plus c. We all know that negative b plus b is 0. 0 when squared is 0. 0 when multiplied by a is 0. So this means we get 0 plus c. So this means ultimately we get c. So now if I tell you directly how to find the coordinate of turning point, so now let's summarize. To find the x coordinate, the function inside the bracket is equated to 0 to give us the value of x, the x coordinate of turning point, and this value which is at the end, which is being added or being subtracted, depends on the sign of it, that would be our y coordinate. So it would be great if you give this, if you can just give some examples so that we can just reinforce this concept. Surely I'm going to do that right now. Let's take few examples. Example number 1, 2x minus 3 whole square plus 5. This is a completed square form, and the examiner has told me to find the coordinates of turning point and also determine nature. This means I have to find the coordinates of turning point and I also have to determine the nature. Now, how can I find the coordinates of turning point and how can I determine nature? For determining nature, we have been told to look at the value of a, the coefficient of bracket. In this case, the coefficient of bracket is 2. The value of a is 2. Is 2 a positive value or a negative value? It is a positive value. Because it is a positive value, this means the point is a minimum point. Positivity, happy face, minimum point. The nature is minimum point, right? Now let's move on to the coordinates of it. For finding the coordinates, the linear function inside the bracket is to be equated to 0. So let's just do that. X minus 3 equate to 0. The function inside the bracket is x minus 3. If you're going to equate x minus 3 equals to 0, the value of x that we are going to get is x equals to 3. So we have got x equals to 3. Now, when we are going to substitute the x coordinate 3 in the original equation, then 3 minus 3 whole squared is 0, multiplied by 2 is 0. So at the end, I am going to get this 5. So if I'm going to get this 5, this means the value of y is directly equals to 5. You can have a question as to why is this plus 5 the y coordinate. So just to justify it, because the x coordinate is 3, and if I'm going to substitute back the x coordinate in the original expression, the value of y that I'm going to get will be 5. So that is why, rather than showing the substitution and then finding the value of y, we can directly say that the y coordinate of turning point is 5. So the y coordinate of turning point is 5. So this means the coordinates of the turning point are 3, 5. And this is a minimum point. So we have determined the nature and we have given the coordinates of turning point. Have we all been able to understand this example, or are there any sorts of confusion? Please share your feedback on the chat, and if you have any queries, you can raise your hand and ask. If everyone can share their feedback, please. Not everyone has done that. Perfect. Great. That's great. Everyone has shown a positive indication that they have understood. Alhamdulillah. Right. So this was the first example. So if I give another example, which might be a bit different, and I'm just going to throw that question towards you, and I'm just gonna tell you to give the coordinates of that turning point and determine the nature as well. So then I'm gonna ask you as to whether you have understood it or understood it or not. Right? So let's take another example. Right. So I have been told to give the coordinates of turning point and determine its nature. Can you please all post your answers? Just work in your registers and just post your answers and tell me as to whether what is the nature of the turning point and what are the coordinates of it. So I'll be more clear as to whether you have understood or not. Write the nature as well as the coordinates, both. Nature of turning point as well as the coordinates of turning point, both in your answers. And then I'm going to tell you individually as to whether you are right or wrong. I expect an answer from everyone, be it correct or be it wrong. I expect to see a reply so that I at least know that you've understood or not. If you are not able to give the right answer, then this means that you have not understood it correctly. Of course, I will discuss the answer for sure. It's my job. I'm definitely gonna do that. If I'm gonna throw a question, I'll definitely discuss it. So, out of the six participants that we had, I got three correct responses and three wrong. So this means not everyone is clear with the concept. So I'm just gonna explain it with this example once again. The first misconception was that it was said that it is a minimum point. I'm not sure how did you conclude that it is a minimum point, because this can't be a minimum point because the coefficient of bracket is negative. We can see that the coefficient of the bracket is negative. Just a negative sign means it's negative 1. So if it's negative 1, if nothing is written, it's a negative 1. So if this value, the value of a is negative 1, then this means it's less than 0. And if it's negative, it's a sad face. And when it's a sad face, it is a maximum point. It's a sad face, it's a maximum point. And then when we are going to move on to the coordinates, I'm not sure how you have given the answer. 2 comma negative 6. I'm still not sure. What I have told you, if you're not going to listen to that, you'll not be getting the right answer. Just follow my instructions. My instructions are very clear. Any function of x inside the bracket is to be equated to 0. Any function inside the bracket equated to 0. So this means 2x minus 1 equals to 0. It is x equals to 1 upon 2. And then the value at the end, which is being added or subtracted, is the value of y. Why? How come? Because when we are going to substitute 1 upon 2 over here, 2 into 1 upon 2 is 1, 1 minus 1 is 0. At the end, we are going to get this negative 8. So why to waste our time in calculations? Just write negative 8. Y is negative 8. So the coordinates are half comma negative 8, and the nature is a maximum point, right? So all those who have done a mistake, have you all been able to connect it now and get it as to how I explained this? All right. So few of the students, I guess, solved the wrong question. The one on the left, this one. That is why they got other coordinates, right? So this was a confusion, and that is why you all got a wrong answer, right? So not a big deal. Even if you're gonna solve it, right? So then every one of you would be right then. All six of you will be right, because if I'm gonna write over here x equals to minus b upon 2a, minus b upon 2 times a, the x is negative 2, and when I'm gonna substitute this x in the given equation, it's negative 2 square plus 4 times negative 2 plus 10, and this is y equals to 4 minus 8 plus 10. And this is 10 minus 8 is 2, 2 plus 4 is 6, right? 10 minus 8, so the coordinates were negative 2 comma 6 as were told by many students, and the nature is a minimum because the coefficient of x square is positive. So this is a minimum point, right? So this was a confusion. That is why you people were not giving the right answers as per the given question, right? Because you solved the incorrect question, right? Perfectly fine, no issues with that. So we are clear till here, right? Every one of us is clear. As I said, Musa, I was to try my best to cover the quadratics, everything, but of course there's so many things, and we are getting stuck up. I'm getting participations. We cannot cover everything. I'm gonna discuss this thing with you people. Don't worry about it. After the class ends, I'm gonna tell you something. Right? So this is what we have done. Now let's move on to how to convert into completed square form is the next aspect. We are just on the first aspect. If I'm just gonna rush up now, then I'm sure not everyone will understand. And this is my very first interaction with so many of you, so I don't think I can just skim through it very quickly, because I'm not even sure about your status, about your caliber. Because if I'm gonna assess you through a test or something like that, then I would be knowing where you actually stand. Because if I'm not gonna assess, if I am just gonna be I move forward quickly, then might be many of you are not able to understand. So that would be a failure for me, and I cannot afford that failure. If I'm explaining it, even if I'm explaining a small concept, I'll explain in a way that each one of you understand. This is my motive. Whatever is being explained, you just get that into your mind, into your heads, so that you will never forget, right? How to convert into complete square form? Let's start with this. X square plus 4x plus 10. Let's suppose it's like this. Now there are multiple methods of this. I'm going to explain the simplest one, the easiest one, right? Examiner says convert x square plus 4x plus 10 into the form a x plus b whole square plus c. We have to convert this into another form. X square plus 4x plus 10 is equals to ax plus b whole square plus c, right? So now what I'm going to do is x square plus 4x plus 10 is equals to a x plus b whole square plus c, the expression that needs to be converted on the left side, the form in which we have to convert on the right side, equating both together, then expanding the one on the right side. How to expand? A remains a, x plus b whole square. We already know how to expand a bracket. A plus b whole square is not just a square plus b square, because this is the major, this is one of the common mistakes of from the students end, that they just do a square plus b square. However, it is a square plus 2ab plus b square, and a minus b whole square is a square minus 2ab plus b square. So over here, if we can just write x square plus 2bx plus b square plus c. It would then be ax square plus 2abx plus ab square plus c. What I've done is the form in which we have to convert, I have just expanded it. And once I have expanded it fully, I have just separated the terms, the coefficient of x squared separate, the coefficient of x separate, and the without x term separately, the constant at the end. And now what I'm going to do is I'm going to compare the coefficients. Comparing the coefficients. Let's compare. If I'm going to compare x squared, then on the left side, the coefficient of x squared is 1. And on the right side, the coefficient of x squared is a. They are going to be equal. So a equals 1. Then comes coefficient of x. The coefficient of x here is 2ab. The coefficient of x here is 4. This means 2ab equals 4. Now the value of a is 1 and b equals 2. A is 1, b is 2, right? Then comparing x power 0. What is the meaning of x power 0? The terms without x, in which we cannot see any x. So ab square plus c. And here we can see 10. We have the value of a1. We have the value of b2 whole square plus c equals 10. 2 square is 4. C equals to 10 minus 4, which is 6. C is 6. When we have found A, B, and C, we are just going to substitute the values in the original expression. In this, in the completed square form, in which we can see the values of A, B, and C. And now we can write the answer. The value of A is 1, we are writing 1. The value of b is 2, we are writing 2. 1x plus 2 whole square plus c. It looks odd when we write 1 because if nothing is there, it would be assumed that there is 1. So let's not write 1 over here. It's just x plus 2 whole square plus 6. So if we are going to write 1 over here, will we be penalized? Of course not. You'll not be penalized, but it's the right way of writing that I always explain, the perfect way of writing a particular thing, right? So this is the final answer. So have you all understood how we have to convert into completed square form? Are we all clear with it? Or are there any confusions? Just share your feedback so that I can move forward accordingly. So over here, we have been able to complete the first category of quadratics, right? We have understood how to interpret the completed square form, and we have understood how to convert into completed square form, though there can be more examples as well, but I'm just giving one example because I think many of you are already clear with it, right? We have successfully ended the first category.